Hey, it's fantastic being here with all of you, and it's quite a thing. I wanted to ask you all what I think is the key question for all of us, really. What if there was a blockchain-based WeChat-like app that had way better privacy than any other app? What would that do for blockchain? What would that do for the ethos? So, when I ask myself that question, can I say, well, okay, I'm a technologist, what would it take to achieve that? And that's what I wanted to try to share with you here a little bit while I'm working on my tan. This thing is emitting a great deal of energy. So we need, obviously, consumers would expect such an app to be as fast as current apps, right? They're not going to wait 10 minutes or something for a payment or to send a message, right? We're talking about integrating payments and messaging with apps or dApps. I mean, that's what WeChat has basically proven that consumers want. It is the killer app. Every other main messaging and payments platform is trying to go for that combination, and WeChat is killing Alipay in China, their home market, because Alipay doesn't have the chat component and the dApp component. So it's clear this is an inescapable fact. So in order to match the consumer expectation, we need fast messaging and payments. The kind of privacy that consumers have with payments today obviously needs to be matched, but the expectation of privacy is going the full distance now. People are no longer fooled by the idea that end-to-end encryption is somehow the holy grail. Okay, they don't want the behemoths in the information technology space to own their data. They want to control their own data, and you can see this in the press. This is a meme that's now finally gone public. People realize that the who talks to who, the social graph, that's the real deal. And of course, if you build it, hopefully they will come, and then you have to be able to have enough capacity. We're thinking 100,000 in a few months, and then transactions per second as peak. You have usually a 10x headroom in a transaction processing system, and then go to 750,000 transactions a second on a single node servers in order to make the economics work out. And then if you talk about security, I've been in this security thing for 35 years. I've looked at a lot of different systems that are used in the defense space, that are used for SWIFT, for example, and so on. I can tell you that national laboratories don't hold out a great deal of faith for elliptic curve-based systems. And no country wants another country to be able to come in and spy on their citizens, figure out what's going on in the economy, possibly target individual citizens, create a kind of terror, take down the economy. Once a payment system is dominant in a country, it is a national vulnerability. This is known from past wars. So these are the real requirements, and I'm just thrilled to be able to tell you that even though no one has been able to achieve this, and we've all been working on it for years, we've got it. But why is it that we at Elixxir can do this and no one else? It's not because for want of effort. it's because the underlying cryptographic tools available have not been capable of delivering these things. So I had to spend a good deal of time and effort to find a real breakthrough that I basically took something I proposed 35 years ago and open sourced, and that thousands of papers have referenced, but no one has found a way to speed up. I sped it up by 1,000x. And that's the one breakthrough here, that when you blow this into blockchain, it looks kind of like this in a, okay, simplified cartoon form. So suppose that Alice wants to be in communication with Bob, but she doesn't want anyone to know that they're in communication, right? It's not just about what she says to him, it's about the fact that they're in communication. Maybe they're exchanging payments, maybe they're, so the essence of a solution to that is shown here by these, okay, silly cartoons. These robots represent the nodes in Elixxir, and they do this like heavy lifting, building these boxes with this permuted plumbing in advance. That's part of the breakthrough. So they build these boxes, and then when Alice wants to send a message and just stuffs it in here, these messages fly through there like Hyperloop. There's no delay. It's only the telecommunications delay. That's what the breakthrough means. So it can be delivered to Bob, and we can then send, and this is actually very important in payments, a reply back through that same tube that will be delivered back to Alice, of course, but that does not violate Alice's privacy because they all come back in a batch, those acknowledgments. And after that, these boxes are destroyed. They're never reused, only used the one time for sort of ultimate privacy. And those, so that's the underlying messaging platform. And on top of that, if we had a payment system that was like cash, in that it is in self-validating denominated chunks like coins or banknotes, then you could just send them through and there would be excellent privacy. So instead of using elliptic curve-based signatures on wallet IDs like other chains, Elixxir has created a new way to do payments that harkens back to the original eCash, which was, as some of you may know, we had an airdrop, and then we had fiat-backed issues by Deutsche Bank, and a US bank and an Australian bank back in the 90s. That was all done using these fixed denominated digital bearer instruments. That was the innovation. And so we need something like that here, but it can't be based on digital signatures as those were. So we want to base it on quantum resistant stuff like simply one-way functions. So, better known as hash functions in this space. So again, sorry for the silly cartoons, but suppose that Bob wants to receive some money from Alice. Now we simplify just to a single $1 coin here. In a simple case, so what Bob does is he creates a random key, and then he hashes that key, and he gives that hash image only to Alice as a kind of an invoice. And then, in order to, if Alice wants to then pay Bob, what she does is she sends two numbers in through the messaging system, just like, I guess I will go back just to remind you. So these could be like text messages or payment messages. If it's a payment message, it's really addressed to the node. So when it comes out, the nodes process the payment. So, pardon me, that's not shown here. Ooh, what's happened? That is not shown here, but Alice, when she sends to the nodes, she sends it through, as we saw, and she sends the two numbers. One is, of course, the hash she got from Bob, the invoice, if you will, and the other is the secret key that Paul created when he, I'm sorry, I misspoke. This is the secret key that Alice created when she received the $1 from Paul. So when the nodes receive this secret key, they simply hash it and look to see if it is, the resulting hash is on the Merkle tree. So this is a tree that only has those hashes that have current value. That's all that needs to be maintained. And if it is there, then they can affect the payment by basically placing Bob's hash on tree and burning or removing Alice's hash. And so then, of course, anyone, including Alice and Bob, can look at the current block and see that Bob's hash is there, tagged as being worth $1, so both counterparties can know that they have what's technically referred to as finality in the payment space, the irreversibility. They know they have the money. Bob knows that only he has that secret key that allows him to spend that money. But if we think back to the messaging system and remember the basics of the Merkle signatures, we actually have room in our system for the reply block that I showed you, that blue check mark. The system can send a Merkle proof of this node being, or this hash being in the Merkle tree back to Alice. So she knows there's finality. She has quantum resistant proof of finality, and then she can use the messaging system to send that to Bob. So now both counterparties have quantum resistant proof of finality without having to wait or look, or just for a few thousand bits are transferred through the messaging system. So it's extraordinarily efficient. And in fact, we've proven that. We've built this stuff and it all works. This is a simple example that we have running in the demo videos where we have 3 nodes, each on a different cloud server. We have automatic deployment with Terraform and Docker, and these are the clients that we've been running for months internally that are based on character addressable console interfaces, a very old-fashioned technology, but the one that lets you try to develop the concepts behind it without worrying about the fancy graphics. And these are the server logs on the 3 different clouds. And this is our Block Explorer, which is live on our website, actually. And so we've been dog-fooding this for our development team for messaging, like I said, for many months. And we've also got the payments working for quite a while. We've been testing those. We don't really use it, but it's works in the same way on the same, all desktops. But the interesting thing is, of course, that it works on the mobile platforms, using actually exactly the same API as on the desktops. And when you look at the performance of the smartphone app, it's comparable to brand X, in terms of data plan usage, in terms of battery usage, and in terms of delay that the user experiences. So we measure all this stuff, and it's all looking really good. So I guess what I wanted to make it one of what's going to be a series of announcements about our progress, and here today for the first time to tell you about our open enrollment for our beta nodes. There's been a tremendous amount of interest in this, not only reflected in the thousands of nodes that operators have signed up, but also, from what we're hearing, and this shows let's say the 6 main steps to the open process that we've developed for how to let nodes into the system, right? If you have the new type of blockchain, not that anyone can operate a node, but the type where there's a set of vetted nodes, like has become quite popular with all the top new chains, which is what you need if you want to deliver a real quality of service performance for consumers, obviously. So we're first asking people what they think the criteria should be and all, and then we're we have a formal application process that we get rid of the spam, and then we're going to publish all the applications, maybe slightly redacted, and then there'll be a process where we will come to an initial decision. Now, there's a dispute resolution for the screening, and then there'll be an open discussion, and then we'll make the final decision, and hopefully this will reflect the will of the community. So this is for the beta, but there's huge significance in this, because really what it is a dry run for the real thing for the mainnet launch. Okay, so this is the process that we're proposing to use for the mainnet, and we're testing it out in real life for the beta net. And so we've got a lot of other material support, like exactly how to build the servers and everything. And so, okay, in the AlphaNet, we've been running the majority of the servers, but in BetaNet, that will no longer be the case. And then when we go to mainnet, we'll repeat this process. Now, hopefully, many of the nodes will continue on, and that has a real advantage to all of us, right? Because you don't want to have an abrupt transition to mainnet. So we want to have a curated, reliable, predictable, optimized way to move to mainnet that's not going to create a lot of surprises and disruption. So this is a key part of it, and I guess maybe you could understand this to mean that ultimately in mainnet, incumbency doesn't hopefully mean anything unless the community wants that. But having people in the BetaNet move to become nodes in the mainnet and at launch will help with the transition. So I'd like to encourage, there are economic reasons to be a node, as you may know, but there are also, it's a matter of showing support, and we've received both kinds of interest. So if you want to really participate, consider this, watch this process. Maybe you want to participate in it. I have to now talk about dApps briefly, the remaining few minutes, because as you know, dApps are the hope that many of us have for the blockchain and for the new distributed world, and I'm on record as having said that I think they will empower a whole new kind of world for people at a lot of different levels. It's an extraordinarily exciting thing, and some other chains have tried to run their smart contracts and maybe even dApps on chain. And with all due respect, I think that is a ludicrous idea. In fact, how can I say that? Maybe I say silly idea, poor idea. Has proven to be a poor idea. Maybe I should say it that way. Because think about it. dApps, some of them want to use video cards. Some of them want to use huge databases. Some of them want to use AI. Some of them need immutability as a main feature, or censorship resistance is a key attribute. There's no one-size-fits-all dApp engine. That's obvious from first principles. On the other hand, what's obvious also is, and proven by WeChat, is that consumers want the dApps to be integrated in with the messaging and payment platform. They think of dApps as kind of like their sort of robot friends or something. They need to have them in the same payments and messaging space for convenience. It seems obvious when you think about it for a second. So what we've done, and I must say we're not unique in having done this, although we felt like we discovered it before others were doing it, but not that they're copying us. But we found a way to run the dApps and apps and smart contracts off-chain, but to give all the advantages and features as if they were running on-chain. So the way you do that is you just take whatever your smart contract or your dApp is, and you find a way to split it into two parts. The part that securely controls its presence on-chain, we do that by multisigs. Those multisigs don't slow the chain down at all. Our technology has a way to do multisig with only a few % extra cost. So that's a highly secure atomic operation. And then the rest of the dApp or the app is done, the so-called business logic, if you will, on a dApp engine platform using the so-called multi-party computations. That's a term that I coined, by the way, when I proved some very significant results related to what's possible with computers. Look at my website, chaum.com, and you'll see some more ridiculous cartoons about this. But we have a dApp engine approach that is a marketplace for dApps that will cover a lot of the applications, and we're looking to partner with this group that has something that will cover all the rest of them. So I think we'll have a very comprehensive marketplace for dApp engines that will leverage the wide consumer footprint of the messaging and payments platform to provide the place where dApps will live. Thanks very much.